Hello, my name is Otto Toro, lecturer in landscape architecture at RMIT University, and I'm presenting on behalf of a team of practitioners in landscape architecture and urban design in Queensland. This paper addresses contemporary issue of vertical growth facing many coastal towns and cities in Australia, which are located within sensitive landscape settings. We provide an innovative framework for assessing and defining building heights using skyline thresholds that respects the broader landscape values. I would like to start with referencing our last year publication in the Journal of Digital Landscape Architecture, which we studied the form and complexity of visual board in Melbourne CBD. Visual board is a 360-degree environment around an observer and modeled as two entities. The skyline cap or skyline threshold is a key indicator of visual board, and intrusions by vertical elements can dramatically change the visual environment and the experience. A project in a coastal town in southeast Queensland, city of Gold Coast, to assess visual impact of urban form resulted in developing a new method to define non-intrusive building heights. Occupying a uniquely attractive natural setting between the coastline and hinterland mountains, the city is facing continuing challenges of infill densification, which are reflected in recent building height overlay and pose threats to these attractive coastal settings and put them at risk of losing their distinctive landscape character and sense of place. This aspect is critical to Australia's Indigenous relationship to the landscape, where land, language, and culture are interconnected. The Gold Coast is continually renewing its built form and is likely to undergo a significant change, involving increased density and height with the planned extension of light rail corridor in the southern part of the city. There are currently multiple designated view corridors which can be potentially interrupted by the building height overlay. The broader scale nature of city adds to the complexity of mapping potential impacts on view corridors. Various landscape and character studies have been undertaken for the city, which are integrated in landscape values study. This study requires the view protection to high landscape values, which includes areas such as forested hillsides, forested ridges, headlands, and water, including estuaries and the ocean. Protection of view corridors to manage city form and transformation has been a common approach in many cities around the world. A review of view corridor intrusion approaches to visual assessment and protection, such as London View Management Framework, Edinburgh Design Guidance, and Portland's Scenic Resources Protection Plan, indicates a high degree of location specificity. None provided an appropriate off-the-shelf and objective method for defining building heights. Consequently, a new approach has been presented in this paper following intensive trailing of various mapping and modeling approaches. This approach utilizes latest advances in urban skyline threshold using skyline barrier function in ArcGIS and use of LiDAR data and a virtual city model. Visual constraints that define the level of building height intrusions can vary from one locality to another. In Gold Coast study, vegetated ridgeline were selected as high landscape values features as they form a layered backdrop to the city and visually frame parts of city at a local and regional scale. The closest ridge was selected as the main parameter for building height intrusion because they are closer to the observer, appear green with some detail of visible vegetation, and they are more important to the local character, scenic backdrop, landscape setting, and district identity. A non-intrusive building height limit can be considered as slightly below the identified skyline threshold, which in this study we considered 6 meters below the threshold to the vegetated ridgelines. This is an example of the skyline threshold modeling from a designated lookout and displays the engagement of views with the closest and distant ridgelines and headlands. By intersecting the skyline threshold to the closest ridge with the building height overlay, the non-intrusive building heights identified as shown in black line. 16 citywide and local view corridors were selected across the study area, which engage with high landscape values within the southern beaches. The field of view corridors was photographed and recorded during the site visit to assist with the skyline threshold modeling. Threshold analysis was conducted from all view corridors by converting all threshold multi-patches to raster elevation and applying an overlay technique. The non-intrusive building height was identified for the study area, which presented in 3D models showing the maximum building heights versus non-intrusive building heights, and photo montages from view corridors to verify the results. The final non-intrusive building height map was achieved for integration in city plan amendments. This urban design tool will assist architects, planners, and developers with identifying and mapping constraints associated with views in order to define building height thresholds and city form. This is a demonstration of all modeled skyline thresholds from selected view corridors to achieve a triangulation of views towards the height-sensitive area. This method will facilitate site-sensitive urban design by enabling local authorities, developers, and architects to be more aware of site constraints so that they can design build form more appropriately. Although the Skyline Threshold tool can also be used to challenge height restrictions on site-by-site basis. This repeatable methodology is applicable to urban centers with views in several directions to multiple landscape features that are important to the character and scenic amenity, and where such views at risk of being blocked by tall buildings.